Hi, welcome back to our third example for 4.2 coterminal and related angles. In this example, it says solve a map problem. So the city plan of Port Foghorn uses a Cartesian grid, with each grid mark representing a distance of 1 kilometer. The plan places City Hall at the origin of the grid. Ted's house is at grid point -6,25. All right, part A, it says the angle of rotation for Suzette's house has the same tangent ratio as the angle of rotation for Ted's house. Where is Suzette's house? Okay, we're going to have to draw this on the Cartesian plane. So we're going to quickly we're going to quickly make a grid with the X and Y axis. So we're told that City Hall is at the origin. And then we're told that Ted's house is at the point -6,25. So if -6 is here and 2/5 is up there, we got a nice point right here. This is Ted's house. We'll call it T for Ted. All right, now it says the angle of rotation for Suzette's house has the same tan ratio as the angle of rotation for Ted's house. So where is Suzette's house? So if this ordered pair is -6, 2.5, then where else could I have a tangent ratio that's negative? So remember tan is going to be the y over the x. So that would give this a negative ratio. We'd have 2.5/6. So where else would tan be negative? Well, we know tan is positive here, and we know tan is also positive down here. So that means it must be down here. If it has the same ratio, it needs to make a congruent triangle with the x-axis. So we're going to draw this out here, and it's going to look like this. So here the x will be positive 6.25, and the y value here will be -2.5. So what's the ordered pair? We could say 6.25, -2.5. So there is a rule that we can use to know where our trig ratios are positive. So there's an acronym for this. So if you notice, I kind of did this one a little bit faster, and there's an acronym called the CAST rule. And what we do is we label the quadrants C, A, S, T. It's called the CAST rule. You can actually use this for all these questions. It lets you know where the trig ratios are positive. Okay, it tells us where they're all positive. The C for cos, A for all, S for sine, and T for tangent. So to use the CAST rule, because C is located right here, the only trig ratio that's positive in this quadrant is cosine. Sine and tan will be negative. Why are they negative? Well, because the y value is negative. Up here, this stands for all. All trig ratios are positive because the coordinate xy, they're both positive. So sine, cos, and tan are always positive in this quadrant. What about this quadrant? Well, just sine is. Why? Because the y value is positive and x is negative. So only sine is going to be positive in this quadrant. And then T here for tan, only tan is positive in this quadrant. So this could make it really easy using the CAST rule. You know where your other trig ratio, where that other angle needs to be to find the trig ratio. Okay, let's see what part B says. Find the angles in standard position if the lines drawn from City Hall to each of the two houses are terminal arms. Round your answers to the nearest degree. Okay, so they want to know, they want us to find the angles in standard position. So we're looking for this angle first. We'll draw this one in black. This is for Ted's house. Okay, I'm going to call this one, I'll call it theta. And then the angle for Suzette's house. Now they want the angle in standard position, so it's always measured from the positive x-axis. and then goes to the terminal arm. So the other one's going to be a big angle. It's almost going to be 360. The black angle, this one here for theta, that's almost 180. So both these triangles have the same angle inside here. Okay, those are both equivalent. Okay, so let's go ahead and try to figure this out. So tan of theta needs to equal, remember my tan ratio, it's always y over r. So it needs to equal 2.5 over -6. So if I want to find theta, I got to do tan inverse. Now, the tricky thing with your calculators is that when you put this in, -2.5 over 6, the calculator doesn't give you both angles. Because notice this is the tan ratio for both of these angles, alpha and for beta. Okay, it's true for both of them. Let me label this one as beta. So both theta and beta, they both have the same tan ratio. Your calculator, though, it's only going to give you one of the answers. It's either going to give you theta or beta. Okay, let's go ahead. Let's see what we get. So tan inverse, and we have -2.5 over 6. Okay, it says -22.619. So that's kind of weird, eh? The calculator gives us a negative angle. So it's actually giving us this angle right here. It's telling us that this in blue rotates this way, and it's 22.6 approximately. Okay, I wrote it as a positive angle because I'm showing the rotation going going clockwise. So remember, any angles that rotate this way are positive. Anything that's negative has to rotate the other way. So when we do this on our calculator, that operation here, it's actually telling us this is a positive 27 here. So what's angle beta then? Well, beta is going to have to be 360 minus the 22.6. So we'll say here beta equals 360 minus 22.6 degrees. So let's do that right here. 360 minus 22.6. I'll grab a couple other digits, 918. We get 337.38. So we're supposed to round in the nearest degree, so I'll have to round down to 337. So that's angle beta. So what's angle theta then? How do we know what this is? Well, remember how we said this was a positive 22.6? Well, that means this is also 22.6 as well. So what's theta? Well, theta is going to equal 180 minus the 22.6. So that's going to give us the 100, and basically you have to round down to 157. All right, so there you have it. That's how we can find some of our angles. That's how we find equivalent trig ratios. I'll see you guys in the next video.